It was a quiet morning, one that felt just like any other. The kind of morning where you step outside, the air crisp and cool, the world waking up in its usual rhythm. The sun hadn't quite fully risen, casting a soft amber glow across the horizon. The city was still stirring, birds were starting to sing, and the hustle and bustle of everyday life was just beginning to pick up. For most of us, it was just another routine day on Earth, nothing to stand out, nothing to make us stop in our tracks. But in the vast, endless expanse of space, something was stirring, something that would alter the way we viewed the cosmos forever. You see, on this morning in December, something happened in the heavens that no one expected. It was something so incredible, so monumental, that it caught us all off guard. For years, scientists, astronomers, and stargazers alike had been watching the moon, waiting for some grand cosmic event. And yet, when it happened, no one could have prepared for the reality of it. On that fateful morning, live images flooded across screens, and the world watched, stunned, as something collided with the moon. The moon, that familiar constant companion in our night sky, had just been struck. The event was as sudden as it was startling, and for the first time in recorded history, we were able to witness it in real time. The initial shock of seeing the impact unfold was almost overwhelming. The collision wasn't some distant, faint speck in the sky. It was vivid, close enough that it felt personal. Astronomers, scientists, and ordinary people alike, all glued to their screens, witnessed the moment as if they were standing right there on the moon, staring into the void. A small object, once invisible to the naked eye, had streaked through space, crossing the vast gulf between Earth and the moon. And then, in an instant, it collided with the lunar surface. There was no prior warning, no alert system in place to prepare for such an event. The object, which seemed to materialize out of nowhere, hurtled through space and struck the moon with the kind of force that left us all speechless. The moon had always been a silent, passive observer in the night sky. We've grown so accustomed to its steady presence, its phases changing in predictable cycles. It's been a symbol of tranquility, of constancy. But that morning, as the collision occurred, it felt like everything changed. The moon, which had for so long been a serene fixture in the sky, was suddenly thrown into the chaos of space. As the object struck, a brilliant flash of light erupted from the impact site, lighting up the surface of the moon. A wave of dust and debris shot into the vacuum of space, sending a shock wave through the moon's surface. The shock wave was felt across the solar system, its energy pulsing outward, affecting the very space around it. It wasn't just the impact itself that was extraordinary. It was the way that moment resonated across the cosmos. Scientists quickly jumped into action. Data from telescopes and satellites began pouring in, and the race to understand what had just happened began. The object's trajectory was studied, its speed and size calculated, and theories about its origins began to emerge. Was this a random asteroid strike, or was there something more deliberate behind it? In those first few hours after the collision, the world was gripped by uncertainty and curiosity. News outlets were filled with footage from space agencies, each providing their own analysis. The moon was forever changed by this event, and our understanding of space, the moon, and its role in protecting Earth would never be the same again. But what exactly had we witnessed? And why was it so important? As we stood on the precipice of discovery, one thing was clear. This was no ordinary event. The universe had just delivered a powerful reminder that there's still so much about space that we don't understand, and we were all witnessing it together. As the initial shock of the collision began to subside, the question on everyone's mind was, what exactly had crashed into the moon? In the world of space observation, we're used to small meteoroids and asteroids making their way through our solar system, often unnoticed. But this object was different. It wasn't like the usual cosmic debris that we've grown accustomed to seeing streaking across the night sky. This was something much more significant, and its trajectory seemed too precise to be a random event. At first, scientists struggled to get a clear reading on the object's composition and origin. Their initial analysis showed that it was no ordinary asteroid. The size of the object, roughly that of a small car, didn't match typical space debris. It wasn't a random chunk of rock floating aimlessly through space. This was something that had clearly been heading directly for the moon for quite some time. The trajectory was too specific. its path too deliberate, and the force of the impact too great to dismiss as an accidental collision. As astronomers analysed the data further, they discovered that the object had come from a distant region in the solar system, one that wasn't easily accessible or often tracked. This raised several important questions. Was this object part of a larger pattern, something that had been overlooked in the vast expanse of space? Or was it an anomaly, an isolated event that had no connection to anything else? The more scientists delved into the data, the more they realised how little we truly understand about the small yet powerful objects that drift through space. Space is vast, and it's constantly changing. What we think we know about the paths and behaviours of asteroids is often based on rough estimations and incomplete data. This event, however, was a wake-up call. As more details emerged, the analysis suggested that the object wasn't just an asteroid. It could be the remnant of a long-lost comet or even an artificial object. Could it have been a piece of an old spacecraft that had drifted into space and wandered across the moon's path? Some scientists entertained the possibility that it was a piece of debris from one of the many space missions conducted over the years. The evidence was unclear, but the potential ramifications were vast. Could this be the beginning of a more dangerous trend of debris impacts? Regardless of its origin, the fact remained that the object had made its mark. The moon, for so long a silent observer, had been struck in a way that left many wondering if the balance of the cosmos had shifted, if we were now seeing a new phase in the relationship between Earth, the moon, and the debris-filled universe around us. But as we sought answers, one thing became clear. The moon had been affected. It wasn't just a cosmic fluke. This was something that needed our attention. For centuries, the moon has stood as a silent sentinel in our sky, its surface scarred with craters from billions of years of cosmic collisions. From the moment the moon was formed, it became a battleground for objects careening through the vacuum of space. Yet, despite the constant barrage of meteoroids, asteroids, and comets, the moon's surface remained mostly unchanged until this moment. The moon's history of impacts is well documented. Every crater tells a story, a record of an event that shaped the very landscape of our closest celestial neighbour. Each crater, whether large or small, represents a violent collision from the deep reaches of space. And these impacts, over time, have created the moon's familiar surface, pockmarked, scarred, and full of history. However, what makes this recent crash unique is the fact that it occurred in real time, with the entire world watching. Previous impacts on the moon were mostly recorded through telescopes, with the data arriving after the fact, sometimes years later. But this event was different. This was no distant explosion in the sky. It was an immediate and visible change to the moon's surface, captured live by our most advanced technology. And while the moon has been bombarded countless times before, this was the first time we'd been able to witness such an event as it happened. Scientists had long known that the moon's surface was covered in craters, large and small, left behind by impacts from asteroids and other space debris. The most famous of these, the large basins visible to the naked eye, were formed during the early days of the solar system when collisions were more frequent. The largest crater on the moon, the South Pole Aitken Basin, is a testament to the intensity of those early impacts. Measuring over 1,200 kilometers in diameter, this massive scar on the moon's surface was likely created by an enormous collision that occurred billions of years ago. These impacts have been a defining feature of the moon's evolution. Unlike Earth, with its active tectonic plates and atmosphere, the moon has remained relatively unchanged. Its surface is a static record of the countless cosmic events that have shaped it. And as each new impact occurs, whether large or small, it adds another layer to the moon's history. But what about the implications of this new crash? It's easy to forget that the moon's surface, though ancient, is still vulnerable. In fact, space is far from empty. Small objects constantly drift through the solar system, many of which cross paths with the moon. While most of these objects burn up in the moon's thin, airless environment, or pass by without consequence, some will inevitably collide with the lunar surface. This particular impact was significant not just because it was captured live, but because it served as a reminder of how vulnerable the moon truly is. For years, we have used the moon as a stepping stone for future missions, planning to establish bases and explore its resources. Yet this impact made one thing clear. We must be aware of the risks that come with lunar exploration. The moon, while our closest celestial neighbour, is constantly bombarded with space debris, and it's only a matter of time before something much larger collides with it. For the first time in history, we witnessed an impact in real time, reminding us that even the moon, our steadfast companion in the night sky, is not immune to the forces of space. And as we look to the future, we must continue to monitor, study, and prepare for the potential impacts that lie ahead. When an object strikes the moon, it's not just a simple collision of rock and dust. The science behind these impacts is far more complex and fascinating. The moon, though seemingly quiet and still, is constantly being bombarded by objects from the far reaches of space. However, most of these impacts are so small that they go unnoticed, even by our most advanced telescopes. But when something large enough hits, the results are far more dramatic, and the consequences ripple through the surrounding space. To understand the impact that occurred that morning in December, we must first dive into the mechanics of such a collision. The object that struck the moon wasn't just travelling aimlessly. It had built up an incredible amount of speed. The speed of an object in space is dictated by the gravitational forces acting on it, how close it is to planets, moons, or other celestial bodies. The closer an object is to a massive body like the moon, the faster it will travel, especially as it accelerates toward its destination. This object, before it struck the moon, was hurtling through space at speeds that could rival a bullet. When it made contact with the lunar surface, the kinetic energy released was immense. Kinetic energy is the energy of motion, and it's directly related to the speed and mass of the object. The faster the object moves, the more energy it carries with it. The impact that we witnessed released a burst of energy equivalent to a small nuclear explosion. While no radioactive material was involved, the force of the collision generated a shock wave, propelling debris from the lunar surface into space. The moon's surface, being covered in a layer of regolith, fine dust and debris created by billions of years of impacts, acted as a cushion, absorbing some of the energy from the crash. However, even with this protective layer, the collision still left behind a noticeable mark. A cloud of lunar dust and shattered rock was flung into space, where it lingered for a moment before slowly drifting away. The moon, known for its quiet, almost serene demeanour, had been abruptly shaken by this event. In addition to the visible effects of the crash, there were also invisible consequences that rippled through the moon's interior. The shockwave created by the impact travelled deep into the moon, and the seismic activity generated by the collision was recorded by sensitive seismometers. These instruments, designed to detect moonquakes, provided valuable insights into the moon's inner structure. The results were surprising. While the moon lacks the active tectonic plates that we have here on Earth, its interior is still not entirely uniform. The shockwave that travelled deep beneath the surface revealed pockets of material that had been undisturbed for eons, potentially offering clues about the moon's geological history. This event gave scientists a rare opportunity to study the moon's composition in a way that had never been possible before. The data gathered from this collision will undoubtedly inform future missions to the moon, and may even alter our understanding of how the moon formed in the first place. The physics behind the impact are clear: high speed, enormous energy, and a deep-reaching shockwave. Yet, it's the effects of this event that will keep scientists engaged for years to come. The study of lunar impacts, both historical and recent, will continue to teach us more about the moon, our own planet, and the ever-changing environment of space. What made this particular impact so unforgettable was the fact that we saw it live. In the past, we've only been able to observe space events through telescopes, receiving data long after the fact. The beauty of space observation is that it allows us to witness cosmic phenomena, but there's always been a sense of delay. Even the most spectacular events, like meteor showers or distant supernovae, reach us after they've already occurred. But not this time. This time the world watched as the event unfolded in real time, as though the moon itself had suddenly come alive. The moon's surface, which had been untouched by major impacts for a significant period, was now the site of a live-streamed cosmic spectacle. This marked a historic moment in space observation. For the first time, the average person could tune in and watch as an object from deep space collided with our celestial neighbour. It wasn't a distant, impersonal event. It was something immediate, something real. The impact was captured on camera, with footage streamed across the world. The flashing light from the collision, the cloud of dust, and the subsequent aftermath were all visible as the world collectively held its breath. Space agencies and observatories had prepared for the possibility of an impact, but the timing was still a surprise. Cameras, telescopes, and monitoring stations all across the globe were ready for the unexpected, and when the object finally struck, they captured every detail. The shockwave, the flash of light, and the moment of impact were all transmitted live, with each frame adding to the collective excitement. It was as if the entire world had become a part of the story, watching together as history was made. But the event wasn't just significant because it was live-streamed. It was a game-changer for the way we study and observe space. In the past, we've had to rely on data sent back from distant space probes or telescopes. Those observations were invaluable, but they often came with a delay. This time, with the live feed, scientists and astronomers could analyze the event in real time, making adjustments and refining their models as the data came in. This immediacy allowed for a new kind of scientific collaboration, where global researchers could share findings, compare notes, and adapt their approaches to the evolving information. The moon had always seemed distant, almost unreachable in its serene silence. But now, thanks to technology and human ingenuity, it had become more immediate than ever before. The moon was no longer just an object of curiosity, a distant body in the night sky. It had become part of our shared experience, something we could witness and study in ways that were once unthinkable. This live observation also raised important questions about the future of space observation and exploration. With advancements in technology, we're now able to observe space in ways that were once limited to imagination. What's next? Will we be able to observe even more distant events in real time? And if so, how will this change our understanding of the cosmos? The possibilities are endless, and this moment of watching the impact live was just the beginning of a new era of space observation. In the years to come, we'll look back at this event as a pivotal moment in the history of space exploration. It wasn't just about the moon, or the object that struck it. It was about our growing ability to interact with the cosmos in real time, to witness and understand the universe as it happens. And that is something truly extraordinary. As we wrap up our journey through the unexpected event of December, when something collided with the moon, and we saw it live, it's hard not to feel a sense of awe and wonder. The moon, for so long a silent and predictable presence in our sky, was suddenly shaken by an impact that sent shock waves rippling through the cosmos. What once seemed like a steady, unwavering body in space became a reminder of just how dynamic and unpredictable the universe truly is. The live-streamed impact that we all witnessed together wasn't just a scientific anomaly. It was a shared experience, one that united people around the world in fascination. In a moment, we were no longer distant observers of the cosmos. We were active participants, experiencing something that would be written into the history books of space exploration. As we watched the flash of light, the eruption of dust and the aftermath unfold, we were reminded of the fragility of the universe and our place within it. This impact, while startling and unexpected, also brought with it a renewed sense of purpose in space exploration. It highlighted how much more we still have to learn about the space surrounding us. The moon, which had once seemed so distant and unchanging, proved to be much more than just a celestial fixture. It's a dynamic, evolving body shaped by the forces of space, impacts, gravitational interactions, and cosmic events that are often beyond our understanding. In the wake of the event, scientists began to ask new questions. What are the risks of future impacts on the moon and other celestial bodies? How can we better track objects in space to prevent another surprise collision? The data from this event, though still being analysed, has opened up a world of possibilities for understanding our solar system and the forces that govern it. The moon's role in our cosmic neighbourhood has always been significant, but this collision reminded us that even the moon is vulnerable to the unpredictable chaos of space. The very forces that have shaped its surface over billions of years continue to shape it today, and the data gathered from this event will inform future lunar missions, both scientific and exploratory. It also raised important questions about the future of lunar colonization, as humanity begins to look toward the moon as a potential site for permanent bases. How will the unpredictable nature of space impacts affect our long-term plans? The answers to these questions will shape the way we approach the moon and its future in the context of human exploration. Moreover, the event served as a reminder of the interconnectedness of all things in the cosmos. The moon, though distant, influences life on Earth in profound ways. Its gravitational pull stabilizes our planet's rotation, creates our tides, and plays a part in regulating our climate. The idea that the moon could be affected by an external object, potentially sending ripples through space that could affect Earth itself, forces us to reconsider just how fragile our existence is in the vastness of the universe. But as much as this event was a reminder of our vulnerability, it was also an affirmation of our progress. In a way, watching this impact live marked a milestone in human achievement. We were able to witness the power of technology and observation, bringing us closer to the mysteries of space than ever before. It wasn't just a live broadcast of an impact. It was a testament to the advances we've made in space exploration and our ability to study and understand the universe. The tools and techniques we've developed to observe space are now so sophisticated that we can study cosmic events as they unfold, instead of waiting for data to arrive from distant probes. And perhaps most importantly, this event reminded us of the boundless curiosity that defines humanity. Even in the face of the unknown, we continue to reach for the stars. We ask questions, seek answers, and continue to explore the vast expanse of space, driven by a desire to understand the universe and our place within it. This collision with the moon, though seemingly insignificant in the grand scale of cosmic events, sparked a fire of curiosity that will burn long after the debris has settled. As we reflect on the significance of this event, we're left with a sense of wonder at the complexity and mystery of space, wonder at the moon's silent history, and wonder at the possibility that the universe is full of surprises we have yet to discover. The moon, that quiet, steadfast companion, has once again shown us that it is not just a passive observer of the cosmos, but an active participant in the dynamic forces of the universe. So, as we look toward the future, we can only wonder, what's next? What other secrets does space hold waiting to be uncovered? The journey of discovery continues, and the moon's unexpected crash serves as a reminder that there's always more to learn, always more to explore, and always more to be amazed by.